Hello. Today Amy and I are going to show you how we use this apparatus, a conductivity tester, to measure the amount of electrolytes present in a solution. So what we have here is two metal probes that we will stick into a solution, and if there's current flowing or a current that can flow through that solution between the electrodes, it will cause this incandescent light to glow. And for the first solution we're testing here is sucrose in water, distilled water, and we're going to show you whether or not there's any electrolytes present in the solution. When Amy turns it on, we see no glowing of the filament, so there's no electrolytes present in this solution. And now, between solutions that we test, we're going to rinse the electrodes to make sure we're not cross-contaminating our samples, since we're measuring those in succession. And this is how we do it. Next, we have a solution of pure vinegar, which is, as you should know, a dilute solution of acetic acid. And when Amy tests this, you see that there is a small amount of ions present in that solution, which can carry current that allows this filament to glow, and you can actually see a little electrolysis happening at the electrodes down there in the solution. Okay, thank you. Again, we will rinse the electrodes with the distilled water before we go to our next solution, which is a solution of table salt. And this is 5 grams of table salt dissolved in 100 mils of distilled water. And when we turn this on, there's lots of electrolytes present in the solution, and you see by the amount of current that flows when you turn it on, and the filament glows a very bright color. Okay, we're going to take a pause here and get ready to show you the samples that you're going to be using in your experiment, and we'll see what kind of results we get there. Okay, for our first sample, we are going to be testing whether vitamin A at a concentration of 4 capsules in 25 mils, we have 100 mils, so we've scaled that up 4-fold, whether that can allow any current to flow when we do this. And for additional help here, we have Bishop to turn on the conductivity tester, and as you can see, we have no current flowing in this particular solution. Thank you, Bishop. Okay, now we're going to be testing a solution of vitamin B12 complex, which has been dissolved in water at a concentration of 1 milliliter per 25 mils of water. And Bishop again is helping us out here. And when he turns it on, again, we see no current flowing through the filament, so there's no electrolytes present in this sample. Our next sample is a solution of vitamin C in water, dissolved at a concentration of 2 grams per 100 mils of water. And Bishop here is going to turn on the current and see whether we see. And we do see a faint glow of the electrode here. So yes, this solution does carry some current, and there are some ions present in that solution. For our next solution, we are testing vitamin D3 present in a concentration of 6 capsules in 25 mils of distilled water. And since Bishop has gone on strike, we have another assistant here who turns on the switch, and no current is flowing through the light bulb at this solution. Now we're going to be testing a solution of vitamin E, which has been suspended in 2 capsules in 25 mils of water, and we're going to have it checked for conductivity, and no current flowing in this solution either. Now we're going to test a solution of vitamin K2, which has been dissolved at a concentration of 1 gram in 100 mils of distilled water. And we've recruited the gardener to turn on the conductivity tester, but there's no current flowing in this sample. Now to switch gears, we're going to be testing some typical mineral supplements that you might purchase. And the first one is going to be calcium carbonate, which has been dissolved in this particular beaker at a concentration of 2 grams in 100 mils. And the gardener has turned on conductivity tester and no current flowing in this one. Here we have a solution of iron sulfate dissolved at a concentration of 2 grams in 100 mils of water. And when we turn on the current, look, we do have a lot of ions present and a very strong glow in the filament. The next solution is a solution of magnesium sulfate present in water at a concentration of 2 grams in 100 mils. And again, when we turn on the conductivity tester, there is a lot of electrolytes present, and we get a strong current flowing through the bulb. We found another recruit for this experiment where we're testing the conductivity of magnesium sulfate at a concentration of 2 grams in 100 mils of water. And when Sasquatch turns on the conductivity tester, we again have very strong current flowing, so it's ionized very well in this water. And our last mineral that we're going to test is zinc sulfate, present in a concentration of 2 grams in 100 mils. And when our buddy turns on the conductivity tester, again, very strong current flowing, so lots of ions present in that solution. And now for some other common dietary ingredients, such as caffeine here. We're going to test at a concentration of 2 grams in 100 mils.
Roar.
And Sasquatch is very disappointed that there's no electrolytes present in that solution. Okay, now we have a solution of glutamic acid. This is a common component known in MSG in your diet. And we're going to test this to see if it's got any electrolytes present. And at a concentration of 4 grams in 100 mils of water, there is no current flowing in this particular sample. And for our last sample, we have the fish oil supplement present in concentration of 1 capsule in 25 mils. And our lab assistant turns on the conductivity tester, and there's no current flowing in this solution. Thank you.